A relation R from a non-empty set A to the non-empty set B is the subset of the Cartesian product A cross B. The set of all first elements of the ordered pair of the relation R is called the domain, and the set of all second elements of the relation R is called the range of the relation R. The first element is less than or equal to the second element. First element is equal to second element, or first element is less than the second element. Hello dear students, welcome to this session of mathematics class. I am Mr. Niranjan, faculty, Department of Mathematics, Vidhyaashram PU College, the Temple of Excellence. Now, today in this session I am going to discuss regarding the definition of a relation and examples and how to find the domain, codomain and the range. Now, let us come to the definition of relations. Now, in the previous class, we have discussed regarding the Cartesian product. The subset of the Cartesian product of the set A cross B is called the relation. Now, how to define a relation R from a non-empty set A to a non-empty set B is a subset of the Cartesian product A cross B. That's it. So, a relation from a set A to set B is the subset of the Cartesian product, that is A cross B. So, how to define a relation R from a non-empty set A to the non-empty set B is the subset of the Cartesian product A cross B. The subset of the Cartesian product A cross B is called the relation. That is called a relation. Now, the subset is derived by describing a relationship between the first element and the second element. By obtaining the relationship between the first and second element, will describes the relationship between A and B and that of the ordered pairs in A cross B. So, now the set of all second elements is called the image of the first element. The second element is called the image of the first element. Now, let us take an example. Now, suppose if A is equal to a set 1, 2, another set B is equal to 2, 3. Now, let us write a relation. Now, first write down the Cartesian product A cross B. A cross B is equal to, the cross product of this is 1, 2, 1, 2, again 1, 3. Next, 2, 2 and 2, 3. This is the Cartesian product. Now, I will define a relation. Define a relation R is equal to a relation x, y such that x is less than or equal to y. A relation R from A to B is defined by a relation R from A to B is defined by a relation R is equal to x, y such that x is less than or equal to y, means this is the relation. That means the first element is less than or equal to the second element. First element is equal to second element, or first element is less than the second element. Now, write down this relation here. From this R is equal to, what is the relation? 1 is less than 2. So, we can take 1 is less than 2. Again, 1 is less than 3. Again, 2, 2 is also equal to 2 and 2 is less than 3. This is called the relation. So, the subset. So, this is the subset of A cross B. The relation R is the subset of A cross B. Therefore, this is the relation. That means, a relation R from a non-empty set A to the non-empty set B is the subset of the Cartesian product A cross B. The subset of A cross B of the Cartesian product A cross B is the relation. So, here all the elements of R are the elements of the set A cross B. Therefore, this is the subset, hence this is a relation. So, it will satisfy the given condition. What is the condition? First element is less than or equal to second element. So, the subset derived by describing a relationship between the first element and the second element. The relationship between the first and second element is, first element is less than or equal to second element. 1 is less than 2, 1 is less than 3, 2 is equal to 2 and 2 is less than 3. So, therefore, we can say that this is the relation. Okay, hope you followed. Now, the set of all these second elements are called as the image of the first element. They are all called the images of the first element, that I will explain. Now let us come to the next definition. What is that? The set of all first elements of the ordered pairs. The set of all first elements of the ordered pairs in a relation R from a set to set A to set B is called the domain of the relation. This is very important. Domain. Domain means the set of all first elements. This is very important point. The set of all first elements of the ordered pairs of the relation of R. That is, the set of all first elements of the relation from a set A to set B is called the domain of the relation. Domain means the set of all first elements of the relation. Now, the set of all second elements in a relation R from A to the set B is called the range. The set of all second elements. So, first elements. First element is called as the domain, and set of all second elements. Second element is called the range of R, the relation, the range of R. So, the set of all first elements of the ordered pair of the relation R is called the domain, and the set of all second elements of the relation R is called the range of the relation R. The whole set B, the entire set B is called the codomain of the relation. The entire set, the whole set, the set B is called as the codomain. So these are very important concepts: domain, codomain, and the range. What is domain? The set of all first elements of the relation is called the domain. Next, what is range? The set of all second elements of the relation is called the range. The whole set B, the set B itself is called the codomain. So, domain, set of all first elements, codomain, the set B itself, and the range is nothing but set of all second elements of the relation is called the domain, codomain, and the range of the relation. And you just keep in mind that the range is the subset of codomain, because all the elements of range are nothing but the elements of the set B. Therefore, the range is the subset of codomain. Let us take an example. Let A is equal to 1, 2, 3, 4, 5, 6. The number of elements are 1, 2, 3, 4, 5 up to 6. Define a relation R. R is defined by R is equal to x comma y such that y is equal to x plus 1. Depict this relation using an arrow diagram. Represent this relation using an arrow diagram, and also find the domain, codomain, and range of R. Now let us find out the relation R. What is the relation given? X comma y such that y is equal to x plus 1. So here the relation is given R is equal to x comma y. That is nothing but what is x comma y? X first element as it is, second element is x plus 1. This is the condition given. So the second element is just 1 greater than the first element. Write down the elements here. What is A? A to A. A contains 1, 2, 3, 4, 5 and 6. Now write down the elements when x is equal to 1. Write down x comma x plus 1. So when x is equal to 1, y is equal to 1 plus 1 is 2. Again when x is equal to 2, 2 plus 1 is 3. When x is equal to 3, 3 plus 1 is 4. When x is equal to 4, 4 plus 1 is 5. When x is equal to 5, 5 plus 1 is 6. When x is equal to 6, we will get y is equal to 6 plus 1, that is equal to 7, does not belongs to A. So, we cannot take this. So, only these are the elements. So, here the relation R is equal to, the elements are 1 comma 2, 2 comma 3, 3 comma 4, then 4 comma 5 and 5 comma 6. So, these are the elements of the set R. So, the relation R is 1 comma 2, 2 comma 3, 3 comma 4, 4 comma 5 and 5 comma 6. This is the relation for this given condition. That means first element is greater than the second element, 1 greater than the second element. 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 1 is 4, 4 plus 1 is 4. That is the relation. So, the relation between first element and the second element is 1 greater than the first element. That is why this is the relation from A to A. Now, here, since this contains 6 plus 1 is equal to 7, but 7 is not in the set A, therefore, we cannot use this element. Now, Next, how to represent this in an arrow diagram? What is A? This is A, and A, the relation. A contains 1, 2, 3, 4, 5 and 6. B also contains, A contains 1, 2, 3, 4, 5 and 6. Now just represent by a diagram. 1 to 2, then 2 to 3, then 3 to 4, then 4 to 5, then 5 to 6. That's all. So this is the representation of an arrow diagram. Now here this R is nothing but the subset of the Cartesian product A cross A. If you write A cross A, then the subset of A cross B is the relation. The subset of A cross B is the relation. So here R is the subset of A cross B. Okay. Now just listen to me here. What is given condition? X comma y such y is equal to x plus 1. X comma y such that y is equal to x plus 1 means, so x is 1, 2, 3, 4, 5, 6. Y is equal to x plus 1 means, when x is equal to 1, y is equal to 1 plus 1 is 2. When x is equal to 2, 2 plus 1 is 3. When x is equal to 3, 3 plus 1 is 4. When x is equal to 4, 4 plus 1 is 5. When x is equal to 5, 5 plus 1 is 6. When x is equal to 6, 6 plus 1 is 7. But 7 is not included in the set A. Therefore, we cannot take 7. So, therefore, the elements of the relation R contains 1, 2, 2, 3, 3, 4, 4, 5 and 5, 6. Now, this is the arrow diagram. Now, what is to write now? Write down the domain, codomain and the range. To write the domain, codomain and the range. Now, let us write down the domain first. Domain of R. Domain of R. So, according to the, just now I explained, what is the definition for the domain? Domain is nothing but the set of all first elements of the relation. Set of all first elements of the relation. The first element of the relation is 1, 2, 3, 4, 5. So, 1, 2, 3, 4, 5 is the domain. The domain of R is the set of all first elements of the relation. Next, codomain. Codomain of R is nothing but, what is the definition? The codomain is nothing but the set B, the second set itself. The second itself is nothing but 1, 2, 3, 4, 5 and 6. That is the set A itself, the codomain. Now, what is to find the range? Range of R. What is the range of R? What is the definition for range of R? The set of all second elements of the relation. The set of all second element of R is called the range. What are the second elements? 2, 3, 4, 5 and 6. So here 2, 3, 4, 5 and 6 comes under the range. So these are the elements for range, then domain and codomain. See here, domain is nothing but the set of all first element of the relation 1, 2, 3, 4 and 5. Codomain is nothing but the set of second element. The set B itself is called the codomain. That is 1, 2, 3, 4, 5, 6. That is A. Now, range is nothing but the set of all second elements of the relation. 2, 3, 4, 5, 6 comes under the range. So, this is how we are going to find the domain, codomain and the range. This is very important concept and very easy. Okay, hope you followed this. Now, let us come to a similar problem. Let us take this example. This is very, very important for 3 marks. This is a 3-marker question. Very important question for the point of examination. So, let A is equal to 1, 2, 3, etc. up to 14. Determine a relation R from A to A by, what is relation given here? R is equal to x comma y such that 3x minus y is equal to 0. Multiply first element by 3 and subtract the second element. If it is equal to 0, then you are going to get the elements of the set R and write down its domain, codomain and the range. Now, let us write down the relation first. What is given here? R. R is given as x comma y such that 3x minus y is equal to 0 means 3x is equal to y. Y is equal to 3x. So, if first element is x, then y is nothing but 3x. That's all. So, this is x comma 3x. That means, now write down the elements here. R is equal to, very simple, if x is equal to 1, then y is equal to 1 into 3. If x is equal to 2, y is equal to 3 into 2 is 6, right? If x is equal to 3, y is equal to 3 into 3 is 9. If x is equal to 4, y is equal to 3 4s are 12. Now if x is equal to 5, if x is equal to 5, y is equal to 3 into 5. This is 15, but 15 does not belongs to the given set A. So therefore we can stop here itself. These are the elements of the set R. R is equal to 1, 3, 2, 6, 3, 9 and 4, 12. If you want, you can verify here. See here. Just put, what is the condition given? 3x minus y is equal to 0. 1, 3. 1, 3 means 3 into x is 1 minus y is 3. 3 minus 3 is equal to 0. The condition is satisfied. So, here the simple way to write these elements are, when x is 1, y is equal to 3 times that element, x comma 3x, 1 comma 3, 2 comma 6, 3 comma 9 and 4 comma 12. Just this is the condition given. So hope you followed this. Just very simple. First element is x, second element 3 times the x, that's all. 1 comma 3, 2 comma 6, then 3 comma 9, 4 comma 12. If you go to the next element as 5, 5 comma 5 3s are 15, but 15 is not in the set A, therefore we cannot take. Therefore, these 4 are the elements of the relation R. Now, let us come to the first one, domain. Domain of R. Domain of R is nothing but, what is domain? The set of all first elements. The set of all first elements, that is 1, 2, 3, 4. 1, 2, 3, 4 is called the domain. The set of all first elements of the relation R is called the domain. And range, I will write the range. Range of R is nothing but the set of all second elements of the relation. Second elements are 3, 6, 9 and 12. This is the range. So domain and range. Now the next one is the codomain. Codomain of R. Codomain of R is nothing but the set A itself, 1, 2, etc. up to 14. This is the codomain. Hope you followed. Listen, here R is equal to 1. The relation is 1, 3, 2, 6, 3, 9, 4, 12. Hence, the set of all first element is called the domain of R. The domain of R is nothing but 1, 2, 3, 4. The set of all first element of the relation. The set of all second element of the relation is called the range. Range is 3, 6, 9 and 12. And the codomain is nothing but the set B itself is called the codomain. That is elements A, 1, 2, 3, 4 is called the codomain. Okay. Suppose if you want to represent this in arrow diagram is just write down A and B. This is A and A. Then just represent 1 to 3, 2 to 6, 3 to 9, 4 to 12. That's all. Okay. Come to the next problem. What is the problem given? Define a relation. Define a relation R on the set N natural numbers by R is equal to x comma y such that y is equal to x plus 5 and x is a natural number less than 4 and x comma y belongs to n. Depict this relationship using the roster form. That means represent this in a roster form. Write down the domain and the range. Now solution. R is given by R is equal to x comma y such that y is equal to x plus 5 and x is a natural number less than 4. X is a natural number less than 4 and x comma y belongs to n. So how to write this in the roster form? The roster form is R is equal to x comma y such that y is equal to x plus 5, y is equal to x plus 5 and x comma y belongs to n and x is less than 4. Now, what are the elements then? Therefore, the R contains here first element is x and the second element is x plus 5. So, when x is equal to 1, the second element is 1 plus 5 is nothing but 1 plus 5 is 6. When x is equal to 1, y is equal to 1 plus 6 is 5. When x is equal to 2, 2 plus 5 is 7. When x is equal to 3, 3 plus 5 is 8. So, therefore, the elements are x comma y, that is when x is equal to 1, 1 plus 5 is 6. When x is equal to 2, 2 plus 5 is 7. When x is equal to 3, 3 plus 5 is 8. And this is less than 4 means all the values of x is less than 4. So therefore the relation contains only 3 elements, 1 comma 6, 2 comma 7 and 3 comma 8, because what is the condition given? X is less than 4. X is less than 4 means 1, 2 and 3. Whatever may be the y value. Y is nothing but a set of natural number. What is they have mentioned? X is less than 4. Okay. So therefore we can take the values of x from 1 to 3. That's all. Now what is to write? Write down the domain and the range. Now therefore the domain of R is equal to the relation set of all first element 1, 2 and 3. 1, 2 and 3. Whereas the range of R is nothing but range of the relation R is equal to set of all second elements, that is 6, 7 and 8. 6, 7 and 8 is the range. So the domain is 1, 2 and 3 and the range of R is 6, 7 and 8 is the range. That's it. Okay. These are all very important type of problems. Even these questions are repeated for second year PUC also. Now let us come to the next problem. Example number 4. If A is equal to 1, 2, 3 and 5 and B is equal to 4, 6, 9, define a relation R from A to B by R is equal to x comma y such that the difference between x and y is an odd number, x minus y. So that is the difference between x and y is odd, and where x belongs to A and y belongs to B, write R in the roster form. So what is the condition given here? 1, 2, 3, 5 in A, B is 4, 6, 9. Define a relation R from A to B by roster form by x comma y such that the difference between x and y. So the difference between x and y is an odd number. It is an odd, where x belongs to A and y belongs to B. So we can write the relation R is equal to x comma y such that the difference between x and y is odd. X and y is odd, and where x belongs to A and y belongs to B. That's all. This is the condition, that the given statement itself is nothing but the roster form. Now write down the elements of R. R is equal to x comma y, where x belongs to A. When x is 1, y is equal to, the difference between 1 and 4 is an odd number, 1 comma 4. So the difference between 1 and 6 is again an odd number. Again the difference between 1 and 9, 1 minus 9 is 8, this is not an odd number. Now let us come to the second element, 2. 2 comma 4 is not an odd, 2 comma 6 is not an odd, 2 comma 9 is 7. So this is 2 comma 7. Right. Next, come to the next element, 3. If I take 3, 3 comma 4, 1 is a odd number. Then 3 comma 6, 3 comma 6, 3 comma 6. Again 3 comma 9, 3 comma 9 is 6, that is not an odd. Now come to the 5, 5 comma 4, then 5 comma 6, 5 and 6 is also 1, then 5 and 9, 5 minus 9 is 4, that is not an odd. Now let me explain. See here. So very simple concept. Just if you take the difference between these two elements, then it should be an odd number. Odd numbers means 1, 3, 5, 7, like that. So 1 minus 4 is 3. Again 1 minus 6 is 5. 2 minus 9 is 7. Again if you come to the second element, 3. Difference between 3 and 4 is 1. The difference between 3 and 6 is 3. Again the difference between 5 and 4 is 1. 5 and 6 is 1. So these are all comes under the odd number. This is 2 comma 9, not 7. Okay, so these are the elements of R. Here what is the range? Range is nothing but the set of all second elements. The domain, what is the domain? Domain is 1, 2, 3, 5. And what is the range? Range is nothing but 4, 6, 9. 4, 6, 9 comes under the range. Okay, This is how we are going to write the elements for the given relation. That's it. Just if we take the difference between the two elements from set A to set B, then it should be an odd number like 1, 3, 5, 7, etc. Okay, that's it. So 1, 4, 1, 6, 2, 9, 3, 4, 3, 6, 5, 4, 5, 6. If you take the difference, you are going to get the odd number itself. That is what the difference between x and y is an odd number. That's it. Hope you followed. Now let us come to the next problem. Now the figure shows a relationship between P and Q. In figure there is a relation which is indicated by an arrow mark. Write this relation in the set builder form, roster form, and also what is its domain and the range. Okay. Now this is the problem given. The diagram is given. In the diagram they have represented the elements by an arrow mark. That is nothing but the relation is given here. 5 to 3, again 6 to 4, and again 7 to 5. The relation is defined indicating this arrow mark. Now what we want to write is, write this relation in set builder form and roster form. What is its domain and range? We have to write. Now first, given that P contains, what are the elements of P? 5, 6 and 7. And what is Q? Q is equal to, Q contains 3, 4 and 5. So these are the elements. Okay. What is P? P is equal to 5, 6 and 7. Q is equal to 3, 4 and 5. If you observe carefully, what is the difference between these two? 5 minus 3 is 2. 6 minus 4 is 2. 7 minus 5 is equal to 2. So the difference between these two is 2. 2 and 2 is the difference. Right. So how to write this? Therefore, this can be written as, first one, set builder form. Set builder form. R is equal to x comma y such that the difference x minus y is equal to 2, where x belongs to P and y belongs to Q. That's all. This is the set builder form. Here, since the difference between these two is 2, 2, 2, therefore we can write it in the form x comma y such that x minus y is equal to 2. X minus y is equal to 2, where x belongs to P and y belongs to Q. So 5 minus 3 is 2, 6 minus 4 is 2, 7 minus 5 is also 2. So therefore we can write the relation as R is equal to x comma y such that x minus y is equal to 2, where x belongs to P and y belongs to Q. Okay. Now that is first one, the set builder form. Now let us come to the second one. Just match, that's all. The second one is the roster form. Roster form. R is equal to, what are the elements? 5 comma 3, 5 comma 3, 6 comma 4 and 7 comma 5. That's all. This comes under the roster form. 5 comma 3, 6 comma 4 and 7 comma 5. Now what is to write here? The domain. Now here the domain of R. So the domain of R is nothing but this P itself. The domain of R is the P. P contains 5, 6 and 7. So the domain of R is P, and what is to write? The range. The range of R is nothing but the elements of the set Q. Elements of the set Q itself is called as the range. The domain of R is nothing but the elements of the set P, and the range is nothing but the elements of the set Q. Because domain is nothing but set of all first elements of the relation. That is nothing but 5, 6 and 7. Domain of R is P. And the range is nothing but the set of all second elements. 3, 4 and 5 comes under the set Q and set P. Now let us come to the next problem. Determine the domain and range of the relation R defined by R is equal to x comma x plus y, where x belongs to 0, 1, 2, 3, 4, 5, 10. Now let us write the solution. This is also a very simple problem. R is equal to x comma x plus 5 such that x belongs to 0, 1, 2, 3, 4 and 5. Now write down the elements of R. So therefore R is equal to if x is equal to 0, then this is 0 plus 5 is 5. First element is 0 comma 5. When x is equal to 1, 1 plus 5 is 6, 1 comma 6. When x is equal to 2, 2 plus 5 is 7. Okay. When x is equal to 3, 3 plus 5 is 8. When x is equal to 4, 4 plus 5 is 9. And when x is equal to 5, 5 plus 5 is 10. So these are the elements of the relation R. That's it. See, what is the given condition? X comma x plus y such that x belongs to 0, 1, 2, 3, 4, 5. So when x is equal to 0, x plus 5, 0 plus 5 is 5. When x is equal to 1, 1 plus 5 is 6. When x is equal to 2, 2 plus 5 is 7. When x is equal to 3, 3 plus 5 is 8. When x is equal to 4, 4 plus 5 is 9. When x is equal to 5, 5 plus 5 is 10. So the elements of x are from 0, 1, 2, 3, 4, 5. Now, what is to write here? Write down the domain and the range. Domain of R. So the domain of R is nothing but, the domain is the set of all first elements of the relation. First elements are 0, 1, 2, 3, 4 and 5. 0, 1, 2, 3, 4 and 5. This is the domain. The set of all first elements of the relation is the domain. And what is the range? Range of R is nothing but the set of all second elements of the relation. 5, 6, 7, 8, 9 and 10. So that is 5, 6, 7, 8, 9 and 10. This is the range. Okay. So here the domain of R is set of all first element of the relation, and the range is nothing but the set of all second elements of the relation. That's it. Okay. Hope you followed. This is also an important problem. Let us come to the next problem. What is the problem? Write the relation R is equal to x comma x cube, where x is a prime number less than 10 in roster form. So what is given here? R is a set x comma x cube such that x is a prime number less than 10. Prime numbers less than 10. Now how to write this in the roster form? R is equal to x comma x cube such that x belongs to prime numbers less than 7 are 2, 3, 5, 7. 2, 3, 5, 7. So that is R is equal to, you can write first element is 2, second element is 2 cube, next second 3 comma 3 cube, next 5 comma 5 cube, then 7 comma 7 cube. These are the elements. Okay. So this can be written as 2 comma 2 to the 4 to the 8, then 3 comma 3 3 are 9, 9 3 are 27, then this is 5 comma 5 5 are 25, 25 into 5 is 125, and the last one is 7 comma 7 into 7, 7 sevens are 49, 49 into 7 is 343. So these are the elements. That's it. Okay, that's all. See here, x comma x cube such that x belongs to a prime number less than 10 is 2, 3, 5, 7. So the elements of the relation are 2 comma 8, 3 comma 27, 5 comma 125 and 7 comma 343. Now what is the domain and the range? The domain is nothing but the set of all first elements. 2, 3, 5, 7 comes under the domain, and the range is 8, 27, 125 and 343. That's it. Okay, hope you followed. Now let us come to a last concept, that is, so far we have discussed regarding the how to find the relation, domain and the codomain. Now the question is, the total number of relations that can be defined from a set A to set B is the number of possible subsets of A cross B is n of A. If n of A is equal to P and n of B is equal to Q, then the number of elements in A cross B is equal to P into Q. Suppose a set A contains P element and a set B contains Q elements, the number of elements in A cross B is equal to P into Q. So the number of elements in A into B is always equal to P into Q, where P is the number of elements in the set A and Q is the number of elements in the set B. For example, here if A is equal to 1, 2, B is equal to 3, here A contains the number of elements in A, n of A is equal to 2, n of B is equal to 2. The number of elements in A cross B is equal to n of A into n of B. Okay, So here n of a is equal to 2 into n of b is equal to 2 into 2 is 4. So we can write number of elements in A class B is 2 into 2. So see here 1 comma 3, 1 comma 4. Again 2 comma 3 and 2 comma 4. If I write the relation A class B, that is nothing but 1 comma 3, 1 comma 4. Again 2 comma 3 and 2 comma 4. How many are there? There are 4. So number of elements in A class B is equal to m into n, that is nothing but p into q. P into q is nothing but 2 into 2 is equal to 4. So the total number of the relation from set A to the set B is the number of possible subsets of A class B. Suppose if n of A contains P and n of B contains Q, then the number of elements in A class B is P into Q. Now the total number of relations is given by 2 to the power of P by Q. This is nothing but the Cartesian product of A and B, number of A class B, the number of elements in A class B. Whereas the number of relations we are going to write is here A is equal to 1, 2 and B is equal to 3, 4 are the two sets. Find the number of relations from A to B. The number of relations from A to B is given by 2 to the power of m into n. So this is nothing but m contains 2 elements and n contains 2 elements, 2 to the power of 4. So 2 to the power of 4 means 2 to the 4, 4 to the 8 to the 16 relations we can write. The number of relations from A to B is 16 and the number of A class B we are going to write is 4. Number of elements in A class B is 4, whereas the number of relations from A to B is 16. Okay, this is how we are going to write. See here, I'll explain. The total number of relations that can be defined from the set A to set B is the number of possible subsets of A class B. So suppose if n of A contains P and n of B contains Q, then the number of elements in A class B is P into Q. For example, if A contains 1, 2, B contains 3, 4, then the number of possible A class B Cartesian product n of A class B is equal to, how many elements are there here? 2. How many elements are there in B? 2 into 2. N of A into n of B is 2 into 2 is 4. See, if you write the cross product, that is Cartesian product, you are going to get the 4. So the number of elements in A class B is 4. Whereas the total number of relations from A to B is always is of the form 2 to the power of P into Q or 2 to the power of m into n. 2 to the power of number of elements in A into number of elements in B. That is 2 to the power of 2 into 2 is 4. 2 raised to 4 is equal to 16. So the number of relations that are possible from A to B is 16. That is 2 to the power of m into n. Hope you followed this. See the difference between these two. Here number of elements in A class B. Here the number of relations that can be formed from A to B. So now let us come to the next problem. Let A is equal to x, y, z and B is equal to 1, 2. Find the number of relations from A to B. So here what is given? A contains number of elements. A is nothing but x, y and z. So therefore number of elements in A is 3. And what is B contain? B contains 1, 2. Therefore the number of elements in B is 2. What is right? The number of relations. The number of relations from A to B. The number of relations from A to B is always equal to 2 to the power of m into n. So this is nothing but m. Suppose if I write this as m and this as n, 2 to the power of 3 into 2. That is 2 to the power of 6. 2 to the power of 6 means 2 to the 4. 4 to the 8, 8 to the 16, 16 to the 32, 32 into 2 is 64. You can write 64. Here 2 to the power of n of A into 2 to the power of n of B. That is 2 to the power of n of A into n of B. That is nothing but 2 to the power of m into n. 2 raised to 3 into 2 is 6. 2 power 6 is 6. So the number of relations from A to B is 2 to the power of 6. So if you want the number of elements in A class B, number of elements in A class B is n of A class B. Number of elements in A class B is equal to number of elements in A into number of elements in B. That is equal to 3 into 2 is equal to 6. So n of A class B is equal to 6. That's all. See the difference? Here number of elements in A class B. Here number of relations from A to B. Okay, this is the difference. So these are few problems based on the relations and how to find the range, domain, and to represent them in an arrow diagram. Okay, so that's all for today's session. Let us meet with a different concept in the next class. Thank you very much.